Okay, today we're going to be doing word problems involving sequences. So a lot of this is going to be review, so I'm going to kind of go through this quickly until there's spots that we get stuck on. So it says write the first four terms of each sequence and then write the recursive formula. The first thing I want to notice is like on the first term, I want to find the first four terms. I don't know the first term, so I'm actually just going to have to substitute my one and see what I get. So really quickly, this should be a sub 1 is equal to, all I'm going to do is substitute that 1 to get an answer. That's going to be 39. To get my second term, I'm going to do the same thing. I'm going to substitute the 2, get a 50. For my third term, I'm going to substitute the 3, get a 61. And for my fourth term, I'm going to substitute the 4 and get a 72. I know I went through that quickly, but we've done this enough times, hopefully at this point, where you understand what's going on. Now, more importantly, you probably should write down the sequence over here. Even though they're not asking you to, it's kind of nice to see just what it is and what it's doing. So it looks like I'm adding 11 each time. That way I know when they ask me the next question, which was find the recursive formula. Remember that the recursive formula has two parts to it. The first part is what is the first term? Well, that's easy. The first term is 39. Let me go ahead and write that using a highlighter. And then the second part is, okay, to get the nth term, what did you do to the previous term? Well, remember the previous term, we write it as a sub n minus 1. And it looks like each time I'm just adding 11 to the previous term in order to get my next term. And we are done with that first problem. Okay, let's jump over to the second problem. Same thing, I want to find the first four terms. So all I'm going to do is I'm going to substitute the 1. So I get 96 times 1 half to the first power. Remember, 1 half to the first power is just 1 half. And when you multiply something by a half, really all you're doing is dividing it by 2. So I'm going to take 96 and divide it by 2. That gives me a 48. To get my second term, I'm going to take 96, raise it to the 1 half to the second power. Let me just remind you that 1 half to the second power means 1 half times 1 half, which is 1/4. And when you multiply something by 1/4, really all you're doing is dividing it by 4. So I'm going to take that 96 and I'm going to divide it by 4. And what I end up with there is a 24. And the third term is going to get 96, 1 half power to the third term. Remember that that's 1 half times 1 half times 1 half, which is 1/8. And when you multiply something by 1/8, you're just dividing it by 8. So 96 divided by 8, that's going to give me 12. And we'll power through the last one, 96, 1 half to the fourth. That's going to give me a 1/16. So take 96 divided by 16, and I get 8. So my sequence looks like 48, 24, 12, 8. Not 8, just kidding, 6. That's what happens when you go a little too fast. And guys, I'm going a little bit fast because I know that the problems are going to take longer, and I don't want this to be a super long video. So because this first part is review, I'm not spending too much time on it, all right? How do I get my first, or to find the recursive part, I need the first term. I know the first term is 48. That part's pretty easy. Second part is, how do I get the next term using the previous term? So how do I get the nth term using the previous term? Well, you're going to take your previous term, which I'm going to write as a sub n minus 1. And it looks like every single time I'm just going to divide by 2. Remember, dividing by 2 is the same thing as multiplying by 1/2. And we are set right there. All right, and then the last one we're going to do letter C. I'm just same thing. We're going to get the first four terms. So I'm going to plug in my 1. That gives me a -4. To get my second term, I'm going to substitute 2. Gives me a -10. To get my third term, I'm going to substitute 3. That gives me a -16. Guys, remember, since this is a video, if I'm going too fast, feel free to pause the video at any point. Again, I just don't want to spend too much time on something that I know you already know how to do for the most part. But if I am going too fast, pause the video, take a moment, and just kind of recap what I did there. So I know to get the recursive formula, I need my first term, which is -4. And I need to write, how do I get the nth term using the previous term? Oh, I forgot to write my pattern. This is -4, -10, -16, -22. And it looks like every single time I'm subtracting 6. Remember that subtracting 6 is the same thing as adding -6. So I'm going to go ahead and just write subtracting 6 here, but do understand that this is arithmetic because I'm adding -6. All right, so there's the review. Hopefully that didn't take too long for you. We're going to go a little bit slower. Hopefully we'll do each one of these problems in 5 minutes. There's 5 of these problems. And so this is going to be at least a 25-minute video, I think. I'm going to try to go fast, but, slow down where I need to. All right, the first one says, Ben's grandmother is starting a college fund for him and tells him that she will be putting $600 in the fund each month. Write the first 4 terms of a sequence representing how much money is in Ben's college fund every month. Now, with word problems, it gets a little bit trickier because we have to sometimes consider this 0th term. Like, what I mean by this is, obviously, Ben's grandmother is putting in $600 every month, right? But right now, inside Ben's college fund, there is absolutely zero money in it. So I would say like the 0th term, like right now, there it would be $0. Now I know after 1 month, then Ben's grandmother will put in $600. So the first term is 600. But do understand there's this like imaginary 0th term out there with no money in it. Okay, so that way when I say, well, what's the first term? The first term is going to be $600. And then what happens the next month? They're going to get another $600, so that'd be $1,200. And then after another month, they're going to add another $600, so that'd be $1,800. And then after another one, they're going to get another $600, so that's $2,400. Is it arithmetic, sequence arithmetic, geometric, or neither? How do you know? Well, we know that this is arithmetic because we keep adding 600. If it's arithmetic, what is the common difference? If it's geometric, what's the common ratio? Well, because it's arithmetic, then I know I have a common difference. And the common difference, we represent that with the letter D, if you remember. I'm going to say the common difference is $600. Write an explicit and recursive formula for the given scenario. So let me remind you the first time. For an explicit formula, for an arithmetic sequence, we started off like this. We're going to write a sub n equals. Oh, you know what? Let me write this a little bit higher because I just realized I'm going to write this down twice. So let me move that to the top. To get your nth term, you are going to start off with your first term. And then we're going to add, because it's arithmetic, the common difference, n minus 1 times. Hopefully that formula looks kind of familiar, like, oh yeah, I remember that one, okay? But now I have more information. So since I have more information, I can actually substitute stuff in for this. So to get my nth term, I'm going to take my first term. Well, what was my first term? My first term in this case was $600 plus my common difference. It just so happens that my common difference also happens to be $600. That doesn't always happen, but it happened here, times n minus 1. And there's my explicit formula. That's nice because anytime I want to know like the 13th term, I could just plug in the 13 and see, well, what the 13th term is going to be, okay? All right, as far as the recursive formula, remember that the recursive formula has 2 parts to it. The first part is telling me where I started. Well, I started at 600. The second part is telling me, like, to get your nth term, what you did to the previous term. So I took my previous term and I added 600. That is my recursive formula. Now, remember that this grandmother is putting in $600 every month. So when they say how much will Ben's college fund have after 10 years, we're not going to plug in 10 because, again, she doesn't add $600 every year. She adds $600 every month. So what we need to do is we need to change those 10 years into months. So we take the 10, multiply it by 12, and say, oh no, we want to plug in 120. Now, guys, we have 2 different formulas. Both of them are going to work. I can either use this formula and find the 120th term, which is going to be my n, and substitute it in, or I can use my recursive formula and know that on the first month, they're going to have $600. On the second month, we're going to add another 600 to get 1200. To get the third month, we're going to add another 600 to get 1800. On the fourth month, we're going to add another 600, and I can keep adding 600, adding 600, adding 600, and I need to do this 120 times to know what the final answer is going to be. I don't want to do that. So recursive formula is nice when the number is small, but the number is not small. So I'm definitely going to use the explicit formula on this case to get the 120th term. I'm going to write the 120th term is equal to 600 plus 600 times, remember that my n is 120. So over here, I should be substituting 119. Let me go ahead and substitute that in my calculator and see what I get. And I'm just going to type all that into my calculator. 600 plus 600 times 119. Hit enter, and the answer I get is $72,000. So after 120 months, there is going to be $72,000 in this bank account. And that is my final answer. All right. I don't know if that took 5 minutes. Hopefully it took less. Hopefully it didn't take more, but we're going to go ahead and move on to the next one. A specific type of bacteria reproduces by splitting into two after a certain amount of time. The bacterial colony started with 6 bacteria. Write the first 4 terms of the sequence representing the population of the bacterial colony after each time they split. So a lot of students think like, oh, when I split it, I'm going to split it into 2 sets, 3 and 3. But that's not what they're saying. They're saying each one of those bacteria is going to split into 2. So the first bacteria is going to split into 2 pieces. The second bacteria is going to split into 2 pieces. The third bacteria is going to split into 2 different pieces. The fourth bacteria is going to split into 2 different pieces. The fifth bacteria is going to split into 2 different pieces, and the sixth bacteria is going to... So when you split all of those, you're going to have a lot, right? In fact, you're going to have 12 because each one of those doubles up. But be careful with this because right now, how much bacteria is there? There is 6 bacteria right now. It has not split yet. So right now, your 0th term is 6. Nothing has happened yet. But after 1 split, then those 6 are going to turn into 12. So your first term after the first split is going to be 12. Now, it's going to split again. Once they split again, each one of those 12 is going to split into double, right? They're all going to split into 2, split into 2, split into 2, split into 2. So that means instead of 12, now you have 24. And then after another hour or the amount of time, we'll call it each hour, right? After another hour, they're going to split. It's going to turn into 48. Then it's going to double up again. It's going to turn into 96. And we are done with our first 4 terms. Is it arithmetic? Is the sequence arithmetic, geometric, or neither? How do you know? I know this is geometric because we keep multiplying by 2. Since it's geometric, then I don't have a common difference. I have a common ratio. Remember that the common ratio you use with the letter R, my common ratio is 2. Write an explicit and recursive formula for the given scenario. Okay, so again, I'll do this one more time. Remember that explicit for geometric sequences kind of looks like the explicit for the arithmetic, but with one little or a couple little differences. To get your nth term, let me go ahead and write this up again. I did it twice. To get your nth term, you're still going to take your first term, but we're not going to add because geometric means multiply. So we're going to multiply it by our common ratio. In this case, that common ratio is going to be the letter R. And instead of multiplying it times n minus 1, I'm still going to use that n minus 1, but this time the n minus 1 is going to go in the exponent. Okay, now that I have that, I have some information. I know that my first term in this case is 12, and that my common ratio is 2. And so I'm going to write this as 12 times 2 to the n minus 1. There is my explicit formula. All right, and then for my recursive formula, remember there's 2 parts to a recursive formula. The first part is, what is your first term? Well, in this case, my first term is 12. The second part to your recursive formula is, what did you do to your previous term to get your next one? So I took my previous term, and each time all I did was multiply it by 2. So I'm going to write it like that. Take your previous term, multiply it by 2. And for some reason, we're talking about Ben's college fund. That's the wrong question. What I do want to ask is, how much bacteria is there after 10 hours? So you have two options. You can either start with 12 and then double it, 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 right? You're going to do that 9 times because remember, it's that n minus 1. Or you can use the explicit formula, which I always prefer to do the explicit formula if the number gets kind of big. So to get my 10th term, I'm going to start with 12. That's my first term. I'm going to double it to the 9th power. Remember, order matters. Order matters. So on your calculator, you can actually type all of that in at the same time and it'll do it for you. But if you're going to do this by hand, and some of you guys will, you need to do the exponent first. So first you need to do 2 to the 9th, hit enter, and then you need to multiply that number by 12. And what you get is after the 10th term, you're going to have 6,144 germs. Guys, that's exactly how germs work. They do double up or split. And that's why sometimes, like when you get a little bit sick, right, you start off with just a little bit sick and then all of a sudden you feel really horrible like an hour later. It's because this is what's happening with those germs. They're like splitting into more and more and more, and they're kind of going up exponentially. So, yeah, kind of interesting stuff. All right, we're done with the front side, and we are 16 minutes in. Need to go a little bit faster. Unfortunately, this question number 3, I think, is the toughest one. So I'll try to do my best to explain my way through it. It says Rami bought a pair of Jordan 1 Retro High Dior's at the peak of the shoe market for $11,000. Every month, the value of the shoes has been decreasing by 5%, meaning every month the shoes only keep 95% of its value. So when I tell you that something goes down by 5%, a lot of students make the mistake of using the 5%. We're not going to use the 5%. We're always going to go off how much you ended up keeping. So if you lose 5% of the value, that means you still have or keep 95% of it. We're going to use the 95% and not the 5, okay? So it says, write the first 4 terms of the sequence representing the value of the shoes. Right now, those shoes are worth $11,000. That is your 0th term, okay? After 1 month, it's going to go down. Now, how are we going to do this? On your calculator, you're going to type $11,000, and we're going to multiply it by 95%. So it should look like this, except most calculators don't know how to handle like 95%. So instead, we're going to change that percentage into a decimal. And if you remember, to change a percentage into a decimal, you take the decimal and move it 2 times to the left. And now instead of a percent, I can type this as a decimal because it's the exact same thing. I'm going to take $11,000 and multiply it by 0.95. So let me go ahead and do that. 11,000 times 0.95. Hit enter. And right now on my calculator, it says $10,450. Guys, do not clear that $10,450, especially if you have a TI-30X2S. We're going to do a trick. Hey, I'm going to take those $10,450 that I see on my calculator right now. Do not hit clear. Leave that answer there. Right now, without pressing anything else, you're going to hit the times button. And when you hit the times button, right away, you should see on your calculator, it's going to say ANS times. That means take your last answer. Remember, my last answer was 10,450. And we're going to multiply that by 0.95. So I hit times 0.95. Right now, my calculator says ANS times 0.95, hit enter, and the new answer I get is 99,200. I'm sorry, not 99,000, 9,900, 275. Wow, I cannot read my numbers right now. $9,927.50. Because it went down another 5%. Okay. What am I going to do to get the next one? I'm going to take that number and multiply that one by 0.95. So again, don't hit clear. You're just going to hit times 0.95, hit enter. And now my new number is $9,431.13. Don't hit clear, just hit it again. So we're going to go times 0.95. And now my final answer is going to be $8,000. $959.57. $8,959.57. I know this one's confusing, but just bear with it. It's not that bad. Is this arithmetic or geometric? Well, this is definitely geometric because we keep multiplying. What am I multiplying by? Well, in this case, I'm multiplying by 0.95. What's my common ratio? My common ratio is 0.95. Write the explicit and recursive formula. Since this is since this is geometric, I'm going to use the formula we used on the last one. Remember, it's your A1 to get your nth term. You need your first term. My first term is $10,450. Please be careful. Do not use the $11,000 because that's your 0th term. That's how much it's worth right now. Right now, nothing has devalued. After one month, then it's going to go down to this amount. So your first term is 10,450. My common ratio is 0.95 to the n minus 1 power. What's my recursive formula? Recursive formula needs your first term. My first term is 10,450. To get your nth term, you need to take the previous term. So I'm going to write a sub n minus 1. And what am I doing each time with that previous term? Well, I'm multiplying it by 0.95. How much would the shoes be worth after 10 months? I'm going to take that 10. I'm going to substitute it into my explicit one. Remember, you could do this over and over and over again, but I don't want to. That just takes too long. So let me go ahead and use my formula. 10,450 times parentheses 0.95, close my parentheses, to the power of 9. Because to get my 10th term, I need 10,450, 0.95 to the power of 9. And the answer I get is $6,586.11. So unfortunately, those shoes are going down in value quite rapidly. All right, the other ones aren't as difficult. So let's see. Patrick's mother told him that he will continue to receive an allowance if he gets a 64 or better on his weekly math quiz. The first week, he scored a 97. The second week, he scored a 94. The third week, he scored a 91, and so on. His quiz scores keep dropping at the same rate each week. Write the first 6 terms of the sequence representing Patrick's weekly score. So I want the first 6. I already know the first few. Let's see. I know the first one was a 97. And then it went down to a 94, 91, 88, 85, and 82. Hopefully you picked up on the pattern, and it's subtracting 3. Remember, I can say subtracting 3, or I can say adding negative 3, which makes this arithmetic. If I'm arithmetic, I really should be saying adding negative 3. What's the common difference? Since it's a common difference, because it's arithmetic, I'm going to write d equals negative 3. Write the explicit and recursive formulas for the scenario. Remember that the explicit one starts off with a sub n. You need your first term, which in this case is 97, plus the common difference, which is negative 3, times n minus 1. Guys, you could have also written that as 97 minus negative 3 and minus 1. I think that looks a little bit cleaner because the positive and the negative are just going to turn into a negative, okay? Both ways work. As far as the recursive formula, remember you need to start off with your first term. In this case, my first term is 97. And to get the nth term, you need to use your previous term for recursive. So take the previous term. What did I do with every single term? I just subtracted 3. So this is my first term, and this is my, to get the nth term using the previous term. On which week will Patrick stop receiving an allowance? Well, I know that for him to get an allowance, he needs to score a 95 64. Nope, just kidding. He needs to score, what does it say? He needs to get a 64 or better. I forgot to be highlighting the word problems. I really should have been highlighting those word problems. He needs to get a 64 or better, okay, for him to get an allowance. Well, if he's not going to get an allowance, then his score needs to be less than 64. So how am I going to write this? He's going to get an allowance when his score is 64 or better. So that means he's not going to get an allowance if his score is 64 or less. So if his score, what's his score? His score is going to be this guy right here. This is his score, depending on the week. So I'm going to write 97 minus 3 times n minus 1. If that score is bigger than 64, he's going to get an allowance, 64 or better. But if his score is less than 64, then he's not going to get an allowance. So this is going to tell me when he doesn't get an allowance. I need to solve for this thing. And I don't know how much you guys remember for solving for this, but we're going to try to get n by itself. I'm going to work from the outside in. So I'm going to get rid of all the stuff on the outside of that n. I'm trying to get this n by itself. So let's get rid of the 97 first. How do I get rid of a 97? That's with a subtracting 97 on both sides. These are going to cancel, and I get negative 3 times n minus 1 is less than. Oh, when I subtract these, I believe I get negative 33. Okay, really weird rule. I need to get rid of that times negative 3. I'm going to divide that by negative 3 on both sides. But when you divide by a negative, you need to switch the sign of the inequality. That's a rule that sometimes students forget. So on the left, I still have an n minus 1. On the right, I have an 11, a positive 11. But because I divided by a negative, I need to switch that sign. So it's not less than anymore. It's greater than. Now I'm going to add 1 to both sides to get rid of the 1. To get rid of that minus 1. And I get n is greater than 12. So what I'm saying is he's going to stop receiving an allowance when the number of weeks is greater than 12. So I would say at week 13, he stops getting an allowance. At that point, it's no bueno. His score would be too low. All right, and we're almost done. Down to our last one. It says a ball is dropped from the top of a 400-foot building. After each bounce, it reaches half the height of the previous bounce. Write the first 4 terms of the sequence representing the height of the ball after each bounce. Remember, he's starting right now. That ball is at 400 feet. That is your 0th term. After the first bounce, it's going to go half the height. So if it's going to go half, that means I should divide by 2, right? So from 400, it's going to go to 200 after the first bounce. Then it's going to go to 100 after the next bounce, then 50, then 25. And how many? They want the first 4 terms. There's my first 4 terms. Is it sequence arithmetic or geometric? Well, I know that this thing is geometric because I'm dividing by 2, but really I should say multiplying by 1/2. It's not arithmetic, so I'm not going to use a common difference. I'm going to use a geometric, so it's going to be a common ratio equals 1/2. Write the explicit and recursive formulas. All right, well, let's see. Explicit. And I just remembered that I forgot to highlight the word problem. I really should have done that. It reaches half the height. It starts at 400. Is what you should have really picked up from that. Okay, explicit. Remember, it's geometric, so I'm going to say to get your nth term, you need to take your first term. My first term was 200. Multiply it by your common ratio, which is 1/2 to the n minus 1 power. As far as the recursive, we need to start off with our first term. Our first term is 200. For the nth term, you need to use your previous term. What am I doing each time? I'm multiplying by 1/2. Dividing by 2, multiplying by 1/2, the exact same thing, but I do have 2 parts to it. How high will it be after 8 bounces? Well, you could keep dividing this by 2, right? Right now, this is first, second, third, fourth term. So I could go divide by 2, divide by 2, divide by 2. That would actually work until you get to your 8th term. Again, me personally, I'm just going to use this formula just because it's easy to use your calculator. I'm going to write the 8th term is equal to 200 times 1/2 to the 7th. Let me go ahead and plug that in my calculator. Some students have been asking, how do you plug in 1/2 in your calculator? You just type 1 divided by 2, because remember, that fraction really means division. So on my calculator, I'm literally typing 200 parentheses 1 divided by 2, close my parentheses, and it even looks like a fraction on my calculator when I type it in as 1 divided by 2. And I'm not done. I need to raise that, so you hit the little arrow button. I mean, when I say that little arrow button, I mean that button that looks like that, okay? To the 7th power, hit enter, and it looks like this ball is going to be at 1.5625 feet. Hardly off the ground at all. All right, that is the notes for today. Thank you for sticking through it. I know it's a long video. If you have any questions, please feel free to ask.